What I'm showing you here are the results of an application that I developed using some standard Microsoft technologies to extract the GPS data from the Trace-Up device. Essentially, the Trace is a GPS puck that attaches to an average surfboard, and it extracts information at a rate of roughly 5 data points a second. Those data points include time, speed, azimuth or direction, latitude, longitude, and elevation. The device has historically given this information back to the user in the form of a graphic on a phone with summary information that looks very much like this graphic at the top here. What I've done is to pare this out into individual data points so that you can actually see and select individual waves, what the specific distance was per wave, the max speed, the average speed, and the elevation drop, something that's not available on the current app. So here we have the summary statistics for the individual day: 15 waves caught, total ride time of 7.6 minutes, 206 yards per average ride. This was on an L41 foil board with a Malico foil. You can select down through each one of these waves, and what you'll see is the red line and the blue lines changing in response to the wave selected. In this case, if we come down to this wave that was roughly 304 yards, what you're seeing is a max speed here achieved of about 20.6 miles an hour. The dark lines show the max speed, the lighter colors show the min. What's interesting with foils is that you often drop down in speed, like here, and you can see the progression of the orange icon as the rider moves down the wave, in that case May. Here, further down the line, the speed dropped off again to a minimum at this point of roughly 13 miles an hour, and then back up to 16 as it progressed down the line. Interestingly, the contours shown in the 3D graphic, which is using the latitude-longitude coordinates to overlay on this picture, are incredibly consistent. These contours are virtually identical to what I experienced going down the line. So each wave can be selected and identified second by second what the max min speed was and where the wave was caught and ultimately ended. In this case, the longest ride of the day was 314 yards, and this only experienced a vertical drop of 1.6 feet. The vertical drop is interesting because in certain cases like this here, it showed the greatest drop occurring about halfway through the wave, and then as it progressed down the line, the elevation stayed relatively static. This is something I've been wondering about for a while in terms of how elevation changes as you drop down the face and then progress down the line. But this is a pretty cool application, and I'd be more than willing to share it on the website for anybody who's interested. Thanks.